Geotechnics, what is it? And is it the same as geotechnical engineering? Is it the same as engineering geology? Well, in today's episode of the Geotechnical Engineering Podcast, I have with me Dr. Vatsal Shah, P.E., D.GE, who's the principal engineer at ANS Geo Incorporated. And we're going to talk about geotechnics. We're going to talk about renewable energy, and Vatsal's going to answer that question that I just asked. And we're also going to talk about how it differs from traditional engineering geology. So I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast.
Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
All right, welcome to the show. Vatsal, how are you doing?
I'm doing good, Jared. How you doing today?
Excellent. I'm doing well. I've been looking forward to this conversation. So glad you could carve out some time to be here with us.
Likewise.
All right, great. Well, if you could tell our listeners a little bit more about yourself, what is it you do on a daily basis at ANS Geo?
Sure. So my name is Vatsal Shah. I'm a principal engineer at ANS Geo. ANS Geo is a second-generation family-owned firm. My background is geotechnics, although I went to school for a civil engineering degree. I specialize in geotechnics for the last 13 years or so of my career. Any given day, I'm doing a lot of different things. Some days I'm doing business development. Some days I'm doing technical review. Some days I'm actually out in the field myself and looking at some sites that have some challenges to them, which is part of being a geotechnical engineer. But I think most days my favorite part of the work that I do is just being a leader and being a mentor.
Excellent. And how did you decide that you wanted to be an engineer, and what led you to geotechnics?
Sure. Yeah. So I think I mentioned earlier that it's a second generation family owned firm. So engineering has kind of been in my blood. I've been doing engineering work since I was 12 or 13. Right. I was working on sieve analyses when I was 14 years old through high school, working through summers and winters, just learning it through my dad's work. And over time, I really just enjoyed, how engineering was really important to our everyday society. I got to go out there and see compaction testing being done when I was in high school. And then 2 months later, the road was opened. I got to see pile driving oversight again when I was in the first couple of years of college. And then 2-3 years later on, the building's up and people are going to school there. So it was a really good understanding to be able to see different things and to be able to see things come to fruition. So that was really important to me.
That's great. It's interesting when you think about geotechnical engineering, geotechnics. A lot of times people have no idea what that is. But I guess you grew up in a home where that was something that was readily talked about. You experienced it. You got your feet wet, so you were into it. So that's good.
Right. Our best work is buried underground.
Exactly. All right, great. And I understand you have a pretty diverse background with experience in geotechnics. Why was it important for you to be a jack of all trades, but a master of one? What do you think about that? Where are you in that spectrum?
So I've been doing geotechnics now for 13 or 14 years. At my prior engagement, I did a lot of different things. I did everything from tunnels, water wastewater facilities, oil and gas facilities, ports and coasts, you name it, kind of across the board. I didn't get a chance to specialize in one very particular skill set, but I think it was really helpful for me to see different types of work, because we all learn things like effective stress and total stress and drawdown in school, but being able to actually apply it and use it across different concepts really solidifies, how interconnected things are. Whether you're doing supported excavation for a project or you're doing tunneling, a lot of the same things do carry from one discipline to another. So it gave me a chance to see how it applies in different disciplines and different types of work that we did. I think being a master of one is also has its benefits to it as well. You get really specialized in something, but I've enjoyed being able to experience different types of work and keep my skill set broad, so I'm able to apply the same concepts across a number of different backgrounds.
That's great. I think one of the really cool things about geotechnical engineering is that there's just so many different things you can experience. You could be in
Yeah.
one jurisdiction and see brand new things after a long time, right?
Hmm.
Okay.
Yeah.
Excellent. And I see that you're a diplomat, D.GE, diplomat as well. Why was that important to you? What is it? I know what it is, but what is
Yeah.
that?
So a Diplomat is a ASC certification. I'll say it's fairly new, even though it's been around for almost close to a decade, the program. And the D.GE is basically, it's a show to yourself, it's a show to clients around you, to your peers, that you really specialize and you made a career out of your discipline of choice. So we're all civil engineers. That's what our degrees say. But for me, I took a lot of training and specialized experience in geotechnics. So it's important for those who are working alongside me, for our clients, for our public, to understand that I'm taking this as a commitment to my own career. So the D.GE helps to basically to showcase that you're really moving forward in a certain direction. The program's pretty rigorous too. As you know, Jared, you have one yourself.
Yeah.
You're interviewed by your peers. You have a certain amount of training you have to go through. You have to have a certain skill set. So it helps to set a minimum bar, almost like your PE, of experience that you have, professionalism that you gain over time, but also that you have dedicated your life into this career. So that's really important to me, is just continue to grow and continue to showcase that this is a decision that I've made, and I continue to grow in that discipline.
That's great. No, it's good to see those letters popping up in more places. So it means that the Academy of Geo Professionals is still growing, which is
Right.
good. Good to be a part of,
And I'm happy to see a lot of emerging career professionals getting that as well.
Agreed.
Yeah.
Agreed. Oh, that's awesome. That's awesome. And what would you say is the difference between, let's say, engineering geology and geotechnics?
Yeah. So I think that there's a common thread there between engineering geology and geotechnics. I think of engineering geology, understanding how the Earth was formed, the landforms that we see were generated over time. And that's a really important piece of understanding geotechnics. And you can't have one without the other. If you're working in New Jersey, for instance, which is where I do a lot of my work, you know the area was glaciated, and you might know that the area has a lot of till. I mean, that's an engineering geology understanding. You understand, I'm expecting to see cobbles and boulders in a matrix of soil. I'm expecting to see dense material. I'm expecting to see weathered and shallowed rock and floating bedrock across the area. That helps you understand your geotechnical program when you investigate the site. It helps you understand constructability. Can we install piles through here? Can a sheet pile go through this area? It also helps to frame what sort of lab testing I should be doing. It helps me frame what sort of design assumptions should I make. You could also be working in different parts of the states. If you're working in Texas, for instance, right, you might have expansive clays. Understanding how those expansive clays were formed through all the glacial outwash over many years really helps you to frame your mindset on, I'm expecting to see this type of soil, which is engineering geology. I'm expecting this sort of topography and this sort of drainage across the area, and that helps you with your design process too. So I think you can't have one without the other. I think you have to have engineering geology understanding to then make you a better geotechnical engineer.
Yeah, I'd agree. It's one of the big challenges as a geotechnical professional is that we're dealing with an engineering material that's natural, right? So,
Yeah, that's right.
trying to understand how it was formed and created really does, right?
Yeah,
Direct how
for
we're
sure.
thinking. So you have to have an appreciation for that.
Yeah.
All right.
I think some of the best engineering, geologists and geotech engineers really do marry up pretty well. When you're working on, for instance, in New Jersey, Langen's office is not so far. You probably familiar with the area, but you have all the, Glacial Lake Hackensack out there in New Jersey. Big, football stadiums and stuff were built out there, 200 feet of clay. But knowing that you have a glacial lake there millions and millions of years ago helps you understand the area was under consolidated, still compressing under its own weight.
Yep.
So, having a snapshot of that sort of information really helps you be prepared in the future for long-term constructability. Because, some of the best mentors I had always told me that you can design something, but if you can't build it, it doesn't really work. So you have to know how you're going to design and then build it too.
That's true. Constructability is very important for what we do. Very important.
Yeah, that's right.
And I understand you do quite a bit in the renewable energy space. So how do geotechnics in the renewable energy space differ from traditional geotechnics? What are some of the things you're thinking about there?
Well, there's a lot of commonalities. I think the theory is still the same, right? Soil is still the soil. You have effective stress and total stress and settlement analyses and elastic and consolidation settlement and things. But it is a little more difficult to understand the scale of these sites. When I first got into geotechnics for renewable energy about 5 or 6 years ago, geotechnics was for small solar farms, for some wind farms. You're dealing with very remote locations. They're far up on a mountain pass. They're in an area that's exposed to get a lot of wind, gust that's coming through. So you're investigating sites that normally aren't investigated. They aren't studied highly, so not a lot of geologic references behind them. And you have to use a lot of your tools to profile a large area with a small number of borings. And that's the geotechnical engineer's calling card, right? We use a 2-inch diameter borehole across a large site, and we have to then make interpretations or extrapolations and use our experience that we've gained over all the years of how material behaves to make good engineering judgment. So for a wind farm site that has a turbine located every couple hundred acres apart, you have one boring each location, trying to plan how a transmission line gets put across the area, miles and miles of transmission line, or how you put access roads through there. You're not putting pavement through, you're putting gravel. You have to compact it over multiple miles of area. You're really trying to deal with geotechnical challenges on a really big scale. When I worked previously on projects that are more local in suburban and urban areas, you have a smaller area. The access of getting drilling rig out there, getting your water out there for investigations is easy. When you work in renewables, you're working in the middle of a farm field, possibly in Oklahoma somewhere. You might be working in Arizona near the Grand Canyon. So you're dealing with different challenges, again, constructability, also with design, and then investigation. How do you investigate a 4,000-acre site with a very limited geotechnical budget?
Yeah, that's tough. And for those kind of projects, I mean, are you is there an RFP that's saying you need to do borings at this frequency? Is there a code you're following, or is this engineering judgment, or just wherever we can land a probe? Like, how are you determining that for your
Yeah,
explorations?
I think there's always a balance between what the owner is looking for and what good engineering judgment is. I think renewable energy is still, I'll say it's newer in some of the realms of other types of work, between oil and gas and rail and transport. So the codes and standards haven't really been firmed up yet. So there's good rules of thumb. There's best practices that the folks who are working in this discipline are following. But you can get a wide variation between what an owner has that's a developed owner that may be doing this for 4 or 5 years, and their understanding of risk, how to mitigate risk, and then how that risk is translated to construction. They may have said, we want to spend a little more money up front in the geotechnical engineering now. They get construction and have this problem down the line. But you also have a few, younger developers and players who might say, well, we want to spend the least amount of money to get this project forward. We're not sure we're going to build it yet. And then dealing with the risk down the line in construction. So there really isn't a lot of standard for it yet. There's a certain rule of thumb that we use. We've been doing it now for several years. We've done 18 or 20 gigawatts worth of work over the last year. So it's been learning with different clients, but you do have to use engineering judgment quite a bit.
Got it. And for those larger sites, like when you're completing geotechnical exploration for a site that's called, let's say several thousands of acres large, I mean, what are some of the things that are coming to mind there?
Yeah, so borings is our workhorse, right? But if you're looking at soil borings alone, again, it's a 2-inch diameter hole over a 4,000-acre site. Even if you put 1,000 borings across the area, you've only profiled a 100th of a percent of that site. So you are looking to figure out how can we get some more information using a limited program. So you might throw in some test pits, another tool in our toolbox. A soil boring tells us relative density and stiffness and what the soil profile looks like. But a test pit tells us constructability. Can we install a trench to this area? Can we install cables? Can we put a foundation down? How does the bigger picture look? If you're trying to put down a wind turbine facility that's 12 or 15 feet deep, the soil borings can give you the information that you need for relative density and all of your elastic settlement analysis and bearing capacity analyses. But you're not really able to see, well, how can we actually construct this site? If you have rock at 2 and 3, 4 feet below grade, is that weathered rock in the soil boring? Did I hit a cobble or boulder along the way? Can I trench if I actually need to? So you have to figure out a way to use a lot of different pieces in your toolbox, whether it's field investigation using soil borings or test pits. Sometimes renewable energy has pull-out testing and plate load testing to optimize designs. A lot of these projects are built, with a lot of optimization to them. They want to save a couple inches of stone for pavement analysis because it's not just a parking lot full of stone. It's 3 miles of a road to get to a turbine. 2 inches of stone really means thousands of truckloads across the entire site there. So you're talking about big dollars that are spent along the way. So I think it's really important as you go through the process to use all the different tools you have in your toolbox between plate load test pits, dynamic cone penetrometer, static cone penetrometer, and through experience, you basically get a chance to understand which is the best for what type of environment you're in.
Got it. Got it. And I'm pretty sure there's quite a bit of coordination that has to happen with just site clearing as well, especially if you're in, farm fields and, how does it relate to harvest? How are you getting in?
Yeah.
How are you getting out? So there's probably quite a bit that you're thinking about.
Yeah, that's right. Harvest is a very difficult time. I can tell you, we've buried a few drill rigs after a couple of rainy seasons, after harvest has been done. We've lost some drill rigs and had corn stuck in tailpipes, going
Wow.
through crop fields trying to get investigations done. There's also a very fine line. I mean, you're working in places like you mentioned, harvesting. Those crops have a cost to them.
Mm-hmm.
So you might be balancing out, should we actually go through and do our work in the beginning of the summertime, or should we wait until the late winter time when the harvest is gone and we're not damaging those crops and having a payment for it? As an engineer, I never expected to be involved in conversations with farmers on how much would corn cost if we were to mow through their field. But it all does, help you as a consultant, as an engineer. You're dealing with not just other engineers, dealing with stakeholders and clients and developers. You have to communicate good engineering to them and say, hey, if we go out there and do it this month, we may spend $15,000 trying to clear crops down. We may want to wait and use that budget for another type of investigation work, reallocate that budget somewhere else. So it's being a good shepherd and being a good partner to help them plan good engineering programs.
It's really good. Really good points. Really good points. But when you think about, let's say, our geotechnical education, think about traditional geotechnical education. Do you think that it allows emerging geotechnical engineers to be ready for a career that supports renewable energy? Is this something we're learning in school, or are we learning it more in the field? I mean, what are your thoughts there?
Yeah, I think that the civil engineering curriculum and the geotechnical curriculum is pretty good at teaching us the basics.
Mm-hmm.
You're still dealing with bearing capacity, you're still dealing with settlements, you're still dealing with pavement analysis and those sort of things, and site investigations. I think it's on a much larger scale. We get exposed to at most typical situations the geology that we're working in. So if I was, raised and trained in New Jersey, I'm used to New Jersey's geology. As a New Jersey engineer for many, many years, I never worked in expansive plays in Texas and Denver. I hadn't worked in gypsum type soils in New Mexico. I hadn't worked in seismic material out in California. So I think the education is certainly there. And I'm a proponent of master's degrees and ongoing learning, but also ongoing learning throughout your normal process. So I think the education is there. I think any geotechnical engineer or aspiring geotechnical engineer and geologist can easily use the skills that they have and leverage that into renewable industry. There's a little bit more to be had too. When you're dealing with wind turbines that are basically big rocking materials that are going back and forth. I've seen bearing capacity in a static situation, but now you're dealing with one-way centricity and two-way centricity. You're dealing with different moments along the turbine. So dynamic soil properties are things that I wasn't really trained with in school through my undergrad or through my graduate program. So I had to learn that along the way. But as an industry, even renewable energy, there's just a wealth of information around. ASC has some good guidance around. DNV has some guidance around that people can look at. So I think geotech engineers are great at learning new things.
Mm-hmm.
We're dealing with material that always changes, so we're always calibrating our mind and learning new things. So I think that the program is definitely there.
Yeah, absolutely right. Absolutely right. If you're, if you want to go into a field where you just stop learning, this is not the place, because you just continue to learn, And I'm sure you've seen the same thing. You talk to your mentors, it's like they're still learning, right? And so it's
That's
like
right.
it never stops. It never
That's right.
stops. All right, great. And I know you're active in a number of different areas, and as an adjunct professor at 2 universities, as a practicing professional, and as a researcher. So what drives you to be active in all these different career paths, especially at the same time?
Yeah, I really enjoy having my foot in all 3 different things.
Mm-hmm.
I think that the best way to learn is to teach. So I really enjoy teaching. I've been teaching at NJIT, which is my alma mater, for almost 7 years now. I taught at NYU for about 2 years as well. And I have been active in a lot of different associations, including ASCE and National Society of Professional Engineers. You just meet a lot of different people. And it's great to understand, because as an engineer, I mentioned earlier, you're not just technical. You're working with a lot of different stakeholders. You're taking a lot of opinions into consideration. You have to understand what theory is available, understand what's constructible, understand what can be designed. And I think the nexus of all 3 of those things really helps to create a good engineer. So for any person listening to the podcast who has an opportunity to continue, volunteering and being involved in ASCE or Geo Institute, being involved in a committee, being involved in any of these processes, it helps to expose you with other people who are in the same industry. So you're learning, you're bouncing ideas off of them. you have a chance to give back and teach a little bit, and you hear feedback on what you know. Someone might correct you and say, hey, actually, I have a different reference for this. You should take a look at this. And that only happens through organic conversation. I think being involved at the educational level, it supercharged me to want to give back and to learn from students. It also forces me to be a better mentor, be a better leader. Now that I'm basically trying to manage a new firm and a new company, it's forcing me to be in tune with, well, how do the current students, young professionals come out? How are they learning? What's their way of learning? What's important to them? And how do we support them in that growth so we can transfer knowledge? Because my way of communicating to somebody else who's my generation could be different than the next generation behind them. So it helped keep me in the loop of how we continue creating good, robust programs for training along the way.
Oh, that's great. That's great. Now, before we take our break, final piece of advice you want to share with the geotechnical engineers out there?
Never underestimate the benefit of field work. I still go out in the field quite often myself, as much as I hate my inbox piling up. I'm sure you do the same way, Jared. It's just, It's fun to get out there. It's fun to see some piles go in the ground. It's fun to see a sinkhole open up and be remediated. But nowadays, I usually grab a younger engineer with me or a geologist and say, hey, come along with me. Let's just go through. On the car ride there, you get to talk about the work. When you're there in person, just talking through how you think through things is really important. And whether it's a senior person like myself, working through and talking through, here's what I'm thinking, here's what I'm seeing, opening that dialogue up, even if you're a young engineer or younger geotechnical engineer, and you're talking to your senior staff on site saying, hey, here's what I'm seeing, what are you seeing in return? That sort of dialogue really helps to create that organic training. So I'd say for all the engineers listening to this podcast, don't forget the field work. I know the office is nice and warm sometimes, especially during winter time, but there's just so much to be learned. There's so much to be trained and knowledge shared. Get back out in the field.
Excellent. Get back out there in the field. You're absolutely right. Well, thank you so much. We're going to take a moment to take a break, and we're going to come right back and close this one out on Vatsal and our Career Factor Safety In segment. Stick around. All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Dr. Vatsal Shah, PE, Principal Engineer at ANS Geo Incorporated. Vatsal, you've already had a very successful career. And when you look back on that career, what's one thing that you've implemented to give yourself, let's call it a factor of safety in your career?
Sure. So I think my factor of safety was just being comfortable, being uncomfortable. Mm-hmm. It's a phrase that I learned a very long time ago, and one that I've carried with me as a long time. It's helped create a buffer, like so that factor of safety of learning for me. I think along the way, when you feel awkward, hey, should I ask that question? Maybe they think I'm silly. You're a little uncomfortable, right? But when you ask that question, you push yourself out of that comfort zone. You learn a little more. You try something different. So I think that factor of safety for me was just always pushing myself out the comfort zone a little bit. If you're feeling a little bit uncomfortable, if you're feeling a little awkward, you're feeling unsure of yourself, that's a good thing, actually. Lean into it a little bit, be comfortable, being uncomfortable about that, and push forward a little more. So I'd share that as my factor of safety.
Oh, that's great. That's great. Well, Vatsal, thank you so much for coming on, and thank you for sharing all the great insights with us. You shared some really great information, and it's going to be super helpful for our listeners. Now, if somebody's listening or watching and they want to reach out to you and get more information, what's the best way for people to find you? In social media or an email you want to share?
Sure. Yeah, I'm pretty active on LinkedIn, vatsal.shah.pe. Email, it's my first name, vatsal.shah@ansgeo.com. And that's basically it. You can go check out our website, ansgeo.com. I'm pretty available. And for all the students I've had in the past, they all know me as Dr. V. You can always reach out to Dr. V whenever you need a hand.
Excellent. Thank you so much. We'll make sure to get that in the show notes. This is great.
Thanks for having me, Jared.
My pleasure. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 65, as well as links to any of the resources, websites, and books mentioned during this episode. Until next time, I wish you the very best in all of your geotechnical engineering endeavors. Peace.